Have you ever wondered why the number of students in a classroom, number of trees in a forest and number of books in a library can only be in whole numbers, while a person's height, weight, temperature, and time duration of this video can be measured with decimal values? In today's video, we will understand two important types of data: discrete data and continuous data. We will learn what discrete and continuous data mean, explore their real-life examples, and understand the key differences between these two types of data. So, let's begin with discrete data. Discrete data refers to data that can be counted and usually consists of whole numbers. It represents separate and distinct values, which means there are gaps between possible values. Discrete data cannot be divided into smaller meaningful parts. For example, the number of students in a classroom, the number of cars in a parking area, or the number of goals scored in a football match are all examples of discrete data because we can count them. Remember, if the discrete data consists of countable values and can take only whole numbers, it cannot have fractions or decimal values. For example, we cannot say there are 10.5 students in a class or 5.4 cars in a parking lot. These values must always be whole numbers. In other words, discrete data cannot be broken into smaller meaningful parts. Another important point is that discrete data changes in separate, countable steps rather than continuously. For example, if 150 students are enrolled in a statistics course, the number may increase or decrease if students join or leave, but it will always change in whole numbers, not in fractions. For analysis, discrete data is commonly represented using bar charts, pie charts, or donut charts. Finally, remember that discrete data is always counted, not measured. Now let's discuss what is continuous data. Continuous data is a type of data that can be measured. It can take any value within a range, like decimals and fractions. For example, the duration of a YouTube video is continuous data. A video can be 5 minutes, 5.5 minutes, or even 5.75 minutes long. Other examples include a person's height, weight, temperature, and distance traveled. In fact, time is one of the best examples of a continuous variable because it can always be measured in smaller and smaller units, such as hours, minutes, seconds, and milliseconds. Continuous data always consists of measurable values. For example, the weight of sugar, salt, or rice is continuous data because it can be measured accurately. Continuous data can take values in the form of fractions or decimals. In other words, it can take any value within a specific range. For example, the height of one student might be 4.56 feet, while another student's height could be 5.25 feet. Another important feature of continuous data is that it can be divided into smaller and smaller units. For instance, the weight of a bag of rice could be 5 kilograms, 5.2 kilograms, or even 5.25 kilograms, depending on the precision of the weighing scale. For data analysis, continuous data is commonly represented using histograms, scatter plots, and frequency polygons. So, we can conclude that continuous data is a type of data that is measurable, can be divided into smaller parts, and can take any value within a specific range, including fractions and decimals. Now that we've understood both discrete data and continuous data, let's compare them side by side to clearly understand the differences between both. Now, let's compare discrete data and continuous data. First, in terms of meaning. Discrete data has clear gaps between its values. On the other hand, continuous data has no gaps and forms a continuous sequence. Second, in terms of precision. Discrete data cannot be made more precise. However, continuous data can be measured with greater precision by using decimals or fractions. Third, in terms of nature. Discrete data is obtained by counting, whereas continuous data is obtained by measuring. Fourth, in terms of values. Discrete data can take only specific, distinct values within a given range. In contrast, continuous data can take any value within that range. Finally, in terms of representation. Discrete data is usually represented using bar charts and pie charts, whereas continuous data is commonly represented using histograms, frequency curves, scatter plots, and other graphs. So, here's an easy trick to remember. If you count it, it's discrete data. If you measure it, it's continuous data. Before we end, here's an interesting fact. Shoe sizes like 7, 7.5, or the 8th of May contain decimals, but they're still discrete data. Why? Because you can only choose from fixed sizes, not any value like 7.32. Your foot length, however, is continuous data because it can be measured to any precision. Did this fact surprise you? Let me know in the comments. Thanks for watching. See you in the next video.